Okay, so today is our last lecture on unbalanced forces. So an unbalanced force means that an object is accelerating. So that means it's either slowing down or speeding up. The only big thing that changes, so your free body diagrams are all exactly the same. You label everything and calculate things pretty much the same. The only thing that's really different is now your F-nets. This is for a non-equilibrium problem. So your F-net is not equal to 0 anymore. Now your F-net is equal to mass times acceleration, which is an application of Newton's second law. So if the object is speeding up, the acceleration will be in the same direction as the moving object. If it's slowing down, the acceleration will be in the opposite direction of the moving object. So then I have an example problem for us to work. So we have a 20 kilogram wagon. It's pulled from rest at an angle of 30 degrees with a force of 25 newtons along, and I know I spelled along incorrectly, so sorry, a frictionless surface. We want to calculate acceleration, displacement, and final velocity. They told us the initial velocity, right? Because they told us it's from rest. So the first thing I'm going to do is draw a free body diagram. And I'm going to say it's from rest, and they're asking me for acceleration. So this is a non-equilibrium problem. So my F-net in at least one direction is not going to be 0. It'll be 0 in the other direction, okay? Because it's not going to go up or down on this surface. It's just going side to side. So on your F-net in the Y will still be equal to 0, but your F-net in the X will not. It will equal MA. So let's draw. So here's my little thing, my wagon. It's 20 kilograms. So I know if it's 20 kilograms, I know I've got FG. I know I'm pulling it at an angle, and usually when you pull a wagon, it's usually going to be up and to the right. So, or up and to the left, one or the other. So I'm going to go up and to the right. And so this is going to be my FTY, and this one will be my FTX. I'm on a sidewalk, so I have a normal force. And it's frictionless, so I have nothing going the other direction because it's a frictionless surface, okay? Like ice. So I know I'm going to go ahead and calculate some of these things real quick, and that way I can sort out what I need for acceleration and travel, okay? So I know that my FG equals mg, so that's 20 times negative 9.81. Okay, so I get negative 196.2 newtons for my FG. My FTY is equal to FT sine theta, and my FTX is equal to FT cosine theta. And my FT is 25 newtons. And my angle is 30 degrees. So I need to calculate each of those. You need to make sure your calculator's in degree mode. That's always super important. All right, so my FTY is 12.5 newtons. My FTX is 21 point, I'm gonna go with 7 newtons. My FTY is up, so it'll be positive. My FTX is to the right, so it will also be positive, so I have the sign conventions correct. So now if I wanted to calculate Fn, well, I don't need Fn, so I'm not really going to calculate it. You can if you want to. So now I can get to acceleration. My acceleration is going to be in the horizontal. So my F-net in the x is equal to FTX, which is equal to not 0 because this is non-equilibrium. Okay, so now it's going to be equal to MA. So if I want to find A, I would just divide both sides by M. So then my FTX is 21.7. My mass is 20 kilograms. So my acceleration is 1.085 meters per second squared. You're welcome to round that to like 1.09 also, I don't care. Whatever you want. All right, so then I want to know how far it will travel in 10 seconds. Okay, so I could use, now that I have acceleration and I know that it starts at rest, I could use my, so this was part A. And now I'll do part B. So I could use S equals VIT plus AT squared over 2. My V initial is 0, so this part of the equation is 0. I know my time, and I now know my acceleration. So it's just 1.085 times my time is 10 squared over 2. So 54.25 meters. Okay. Then I just have to find my final velocity. Was its velocity after 10 seconds? Well, oh, that's part C. I like the acceleration equation for this one. So I'm going to say A equals V final minus V initial over time, because my V initial is 0. So if I want my V final, I'm just going to multiply both sides of the equation by time. So then my V final equals 10 times my acceleration, 1.085. And that would give me 10.85 meters per second. Okay, and that's how you solve an unbalanced equation.